that's what the view looks like in the back of the truck. I can't wait to get into that and share that with you all. But for now, we're just enjoying a nice little drive through the countryside. Well, it was quite a pickup. These are the video recorder things that go on public transportation buses and those kind of things. I have on the cart, each stack is 13, and then there's 6 of them, so that's 78. And then in the truck I still have, that one is 79. There's one up in the driver's seat that I was looking at, that's 80. And then we have 81, 82, 83, 84, 85, 86, 87, 88, 89 total. These are older models. These older ones here are the DR500s, and then these other ones I think are DR600s is what all of these are. Before we get into the details of the scrap, I wanted to give you a lay of the land here, or the device, if you will. You see on the right is the DR600 complete, and then on the left is an opened up unit. What should jump out at you right away is that gold corner BGA chip right there in the center towards the bottom. You see yellow tantalum is scattered throughout. There's a navigation card over towards the left side that has some gold plated connectors on it. That's going to be interesting to take a look at. Flat packs all over the place, some MLCCs, some gold edge crystal oscillators, a RAM card, gold RAM card, and a few other bits and pieces. And we're going to see all these in greater detail here with the scrap, but I just sort of wanted to give you an idea of how it was laid out before we started looking at each piece individually. All right, and real quick, let's take a look at the other side. And here we can see that we've got some military grade connectors. So those are always really nice because the gold plating on those pins is usually pretty good to get after. All right, let's dive into this scrap. Now, the first thing we need to do is take the face plates off of either end. And let's find out. So that's stainless hardware. That's kind of nice. Get a special little container and keep the stainless hardware separated until we throw it in with the rest of the stainless. And this access port for the data card, those are just thumb screws, and then that comes off. That's aluminum, and I'm guessing, I don't want to guess. Let's find out. Right, so we've got a piece of aluminum with ferrous thumb screws. We'll deal with that later. And in here we have the data card. Much smaller than what the 500Cs were using. So this is a compact flash net list. All right, so a compact flash card. We'll look that up, see if there's any value in that on the resale market before we do anything with those. And this is the side that has the military grade connectors, a male and a female, or the military style connectors, male and female, and then the network hub. Plus it has a gold plated GPS antenna connection. That's just spinning, so probably not either that. Same toes, so we'll get there later. All right. Sorry about that, folks. Now that whole plate just slides right out of the shell. And we have this nice piece of shell here. This is aluminum. Let's make sure this other end is aluminum here. You're all aluminum. This faceplate is ferrous. There we go. All right, so this faceplate is ferrous, but the rest of the shell is aluminum, and that is just one. There's no seam at any of these joints, so this is just a big piece of extruded aluminum. So that's going to be a real nice addition to the painted extruded aluminum. Yeah, that's pretty heavy too, so let's go ahead and find out just how heavy that is. All right, so each one of those shells, and I have 70 some shells, is 4.6 pounds of, just the shell itself is 4.6 pounds of aluminum, painted extruded aluminum. All right, so now we have the inside. Now, remember with the DR500s, this board was sitting on top of the main board. So a little different configuration. It's now just spread. There's still two boards, but they're laid flat. We still have some very nice components on this board. So we start with the military style connectors here, and those were gold plated pins. This was a network connector here. We have the navigation port for the GPS, that's gold plated. We're going to have this insulated copper wire. That connects to a gold plated connector here. This will be the navigation board. So this is a nice board here. We've got the gold-plated connector. We've got a couple of small tantalums, an IC chip, and I'm guessing there's going to be a chip underneath of this heat spreader. Let's go ahead and see what that reveals. Oh, okay. Well, what you see here are a couple of three small BGAs, a gold edged oscillator, and this has gold sheen to it. This would, I don't know what component that would be though, right off the top of my head. And just in case we missed it. So we've got 3 BGAs. I know that looks like one, but that is actually 2 BGAs. There's number 3. There's a gold edged crystal oscillator and a number of other small, very tiny components on that board. I see a couple of yellow tantalums. These are gold plated pins here. Thick film resistor. So not a bad little board. Definitely go in with the you know, we're going to pull that, we're going to pull these, probably pull these pins, and then this will go in with the mid-grades. Underneath of that was a flat pack and some more tantalums. So the latch for pulling this out was underneath, was on the bottom of this. So somehow you're supposed to be able to push down on that latch to pull out the pin. Weird. Anyway, there's going to be gold plated pins in there. This is definitely a gold connector end if you are collecting those for board to send off to board sort. Get a couple wires out of the way on this end. Alright, so we've got gold jumpers on gold plated pins, tantalums all over the place, of course, copper toroids, ribbon wire, a whole bunch of ICs and some FETs, and some gold edged crystal oscillator. 1, 2, 3, 4. We have a small ram stick, and what are you? 64 megabytes, a whopping 64 megabytes. Don't get carried away now. Gold cornered BGA, so in black tantalums or niobiums. We have a LCD screen over here, so we'll keep that for the indium tin oxide. We have an aluminum heatsink here with some big FETs on the back of it, so we will pull that and keep that. And probably going to be gold plated pins on this ribbon wire. Big cap. Actually, that's not a cap. That's an inductor. Okay. All right, let's go ahead and get these boards up and out of the way and see what's underneath, see if there's anything on the back side of these boards. I don't think so. There isn't a whole lot of room, so I'd be surprised if there's much of anything on the back side of these boards. And I'm not going to make you watch me take all the screws out. I'm going to do that off camera. Be back in a minute. So that turned out to be a little bit of an exercise because of the way the board was tucked in underneath of a couple of things. Kind of had to scoot it back and slide it, and anyway, we finally got it out. And a couple of things that I want to show you real quick while I got this out of the way. Here a minute, get this ribbon wire out of the way. So here's the nice big FETs I was talking about. We'll get those. More tantalums, more ICs. Some MLCCs down in here, so that's nice. And a socket-mounted flat pack here, battery here. And it's just little things I was picking up on as I was hunting for screws. You know, I noticed a bunch of these things, right? And then here we have a whole bunch of little thick film resistors. So if you're into collecting those. Let's take a minute to talk about thick film resistors and why some people collect them. Thick film resistors frequently contain a very rare element called ruthenium. Ruthenium, by the way, that's the Latin name for Russia. And that's because, you know, that's where it was first found in the Ural Mountains. But it's also found in North and South America. The main producers are South Africa, Russia, and Zimbabwe. So even though it's in North America, it's not a main producer. It is a member of the platinum group and is frequently alloyed with platinum and palladium. It's also used in the jewelry industry in addition to the chemical industry. So it's not just electronics. Because it's so rare and it's used through a number of different industries, there's the possibility that it might be something that you want to collect. Now, there is a recycle market for it. In fact, the United States is one of the top 3 countries for recycling ruthenium. So, you know, it might be something that you want to go ahead and pull if you are planning on selling off components. Here you can see this close up on the board. You've got tantalum, yellow tantalums with a ruthenium in between them, and then over towards the right you've got some more ruthenium, thick film resistors, and a MLCC string, interestingly enough. Okay, just a little diversion there into thick film resistors and ruthenium to help further things along. Let's get back to this scrap. This has quite a few of them. All right, let's flip this over, see what we got on the back. And we got nothing on the back. So we've got some little tiny screws here that are holding the connector pins in place. We've got some teeny tiny little MLCCs and stuff, resistors and things on here. I might pull these. These MLCCs are big enough that those might be worth pulling. All right, so again, my goal is to try to get my yard to take these as high grades. So I'm going to pull the BGA, maybe a flat pack, the gold edged crystal oscillators, MLCCs, tantalums, and I think that'll be it for this board. Of course, the battery has to come off. And then over here on this board, some MLCCs, the gold-edged oscillator, the resistors, the jumpers. Worst that happens is when they look at them at my yard, they say, nope, those are mid-grades, and they chuck them in the mid-grade bucket. So, you know, that's no big deal. All right, so that's the DR600 board. I don't know, I guess that would be the main board, and that would be the auxiliary board, power board, I guess. So, and remember in the 500 they were configured like that, so very similar, just a little bit different layout. Okay, so we had you'll recall that there was a LCD screen on one side that had to come off. Here's the LCD board, and this is a pretty classic looking LCD board. It's got these little twist tabs that you line up with the slots, take off the metal screen, and I'm going to need, I think this will work. Okay, and then once those twist tabs are lined up, you can take off the metal housing. That reveals the glass. The glass is, this is where the indium tin oxide would be, so that goes into, that will go into my container for screens. And then we have the rest of the light source and the gold-plated card itself. That's going to be a little light, chip underneath of that. So you can either throw this in with a mid-grade, or you can plan to put it in with dirty gold-plated gold finger type things. We got resistors, so thick film resistors along here. So I got to decide what I'm going to do with that. I don't know. We'll set that off to the side for right now. And then the board that was mounted on has some ICs and a tantalum, gold-plated pins, ribbon wire. So just a mid-grade. On the other side of the steel shell was the plate, the face plate with the male and female military style connectors. J1, J2 is what they're labeled. And we've got all the screws off of this. So might just be needing a little tap to get loosened up here. Yep. Sorry, I had to use the edge of my workbench to hold that, but that just taps down like that. Because there's a rubber water resistant seal that it was glued to the metal plate with. All right, so that's kind of yucky, but that's all right. We'll deal with that, and then we'll cut these connectors off, and then these will go into the bucket of these military grade connectors for pulling these gold plated pins out, because that's usually really heavy gold plating in there. And we want to get this gold-plated connector off here. Looks like that's just going to be a screw. That loosened up real well. So we got a gold-plated nut, gold-plated locking washer, the connector itself. All right, so those will all go into the gold-plated bits that will have to probably be reverse electroplated to get that off. All right, and then this is just steel. The nuts on this thing were a real pain. Turns out they were 5/16, and one of them was kind of buried, so I wasn't able to use the ratchet or screwdriver